We've talked about in that last section, I think they talked about similar polygons. So we had more than just triangles, didn't we? We had 4-sided, 5-sided, 6-sided figures and that kind of thing. Today we're going to get more specific about just triangles. And we're going to talk about similar triangles, okay? So let me just kind of scooch this over right here. Now, what did we have to know before in order to say that the triangles were similar to each other? Well, we had to know that the corresponding angles were what?
Congruent.
Yep, congruent or equal. So if these two are equal to each other, and these two are equal to each other, and what else? This one and this one. Okay. Is that enough so far anyway? Is that enough to say that they're similar triangles? No, you also had to say what else? We'll call this A, B, C. We'll call this one D, E, F. All right. So these are the sides. Now, does this mean in order to be similar, does A have to equal D? No, they don't have to equal, but what do they have to do? It'd be in proportion, that's right. Okay, so if I compare A to, I'm sorry, not B. If I compare A to D, right, those are the corresponding sides. And what else? Let's go in order. Let's go B to what? E, right, because those two would match up, wouldn't they? All right, and what else? C to F. All right, so that's basically how many things? 3 angles and 3 ratios. So that's basically 6 things that I have to know, isn't it? All right, in order to say that they're proportional or they're similar to each other. Matthew. All right, so that's 6 things I would have had to say. But do you remember back when we did congruent triangles? Remember we did side, 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 angle, you know, angle, side, angle, and all that kind of stuff. Everybody's paying attention here? Benjamin, are you? You taking notes on this? You're not doing anything. Everybody's looking at you, right? I don't want them looking at you. I want them paying attention up here. Ben. Okay. So let's just, we'll just pay attention then. All right, everybody looking up here. So, and I just bragged about you guys too to Henry. I said this is the class that really pays attention and wants to learn. Okay. So here we go. Look. That was 6 things. Remember with congruent triangles? At first, we said you had to show all 3 corresponding angles equal to each other, and you had to show all 3 corresponding sides equal to each other to say that they were congruent. But then we said, well, wait a minute, we don't have to show all that stuff. Really, all we got to do is just show 3 sides equal to 3 sides. And then we said 2 sides and an included angle, right, equal to each other. Then we said 2 angles and an included side. Remember doing that stuff? This is kind of the same thing. It's very similar to it. All right? Use that word similar. What if we
oh, I get it.
Watch this. Actually, let's grab this and let's grab this copy and then we'll paste that. All right, so I don't have to go through it. We'll just use the same triangles. Oops. There's that one. The Grand Ole Opry in Australia. I think you got the wrong country and city and everything else. No. The Grand Ole Opry is in Nashville, Tennessee.
Yeah.
It's the Grand Opera House.
Oh yeah.
It's not the Grand Ole Opry though. All right, let's take a look. I'm gonna go through these really quick. We got like 6 minutes left, or maybe 5 minutes. Here's a theorem that says that all I have to do. Now, I'm not going to go through the proofs of these. I believe that some of the proofs of these are actually in the book, so if you want to look at them, you can. But here's the first thing. Whoever's whistling needs to stop, please. If these 2 angles right here are equal to each other, and if these 2 angles are equal to each other, we've talked about this in another chapter. If 2 angles are equal to 2 angles, what must be true about the third angles? They must automatically be equal. So really, all I have to do is say if these 2 angles equal these 2 angles, that means all 3 are going to equal, right? Now, if I did this, if I took a triangle and I had one set of angles equal and another set of angles equal, automatically that's going to make these sides in the same proportion. Okay? I don't even have to say that the sides are in proportion. All I have to say is that these 3 angles equal these 3 angles. That automatically makes these 2 triangles what? No, not congruent. Similar. The triangles are similar. The sides are proportional, okay, but the triangles are similar. So this triangle would be equal to this or not equal, similar to this triangle, just because of this. I didn't have to know all 6 things, did I? I only have to know 2 things. I have to know that 2 angles of one triangle equal 2 angles of another triangle. Just that alone, allows me to say that these two triangles are similar. So now, if they're similar to each other, what now must be true about the sides? They must be in proportion, okay? So this, and if I compare this one to this one, it's going to have the same scale factor as this side to this side and the bottom to the bottom. You follow me on that? Okay, we have a name for that. We call it the side-side, I'm sorry, I lied. The angle, I'm getting ahead of myself. The angle similarity. Shh, stop with all the comments. Let's just pay attention now. Angle similarity postulate. I think it's postulate. I might be wrong. It could be theorem. Yeah, it is postulate. This one's postulate. The other ones are theorems. Okay. So watch. It's the angle similarity postulate. Now that doesn't work with congruency. Just because I have this triangle having two angles equal to this triangle, does that mean that these triangles are necessarily congruent to each other? Absolutely not, because look, these two triangles right here obviously are not congruent to each other. So just because you have two angles equal to two angles does not mean the triangles are congruent. But it does mean that they are what? Similar. Okay, so they are similar to each other. Okay, here's another one. Let me just get rid of a few things here. Get rid of that, get rid of this, get rid of this. Okay, here's another thing. Watch. What if I was given that this angle was equal to this angle, and actually, let me do this one first. Sorry, I'm going out of order. Let's go in order. What if I knew, I'm going to use the same exact letters that we used earlier, okay? What if I knew this? What if I knew A over D equals B over E and it equals C over F? What if I knew that? They told me that. Or they had numbers in there and you could figure out that they all, were the same fraction. That alone, without knowing any of these angles whatsoever, that alone tells me that guess what must be true about these two triangles? They are similar to, oops, that's a weird similar. There we go. That they are similar to each other. Now, it's not called the angle similarity because I don't have any angles that I know. But the sides are not equal to each other. The sides are proportional, so we call it not just side, 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 but what? Side, 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 similarity. That's right. Okay, that's called the side similarity, and I believe they call that theorem. Okay, all right, so that's a theorem. So that's something that can be proven. Now the other one I said look for a proof, but it's a postulate. You can't prove a postulate anyway, can you? So the other one you just accept as fact. This one you probably could prove. All right, so that's side similarity. Make sense? All right, let's do this. Let's say. Let's throw this one out and let's throw this one out. And watch this. What if I knew this? What if I knew A to D and I knew B to E? All right, I didn't know the third one. But I also knew that this angle right here, I don't know, we'll call this capital A and capital B. All right? What if I knew that capital A was equal to capital B right here? This would be side what? Angle side what? Similarity. So if I knew that this stuff was true right there, if I knew that stuff was true right there, what can I say about my triangles? They are similar. And it's not because of side similarity. It's the side angle side similarity. You okay with that? And there is no angle side angle similarity. Okay. Actually, there kind of is, but think about it. Do I really need it though?
No.
Because look, I don't even have to know anything about that side, do I? Because I already got two angles. That's all I need to know, isn't it? So that's why they don't throw an angle side angle in there, right? Because I already know the two angles. And that basically is it, okay? Now there is a example that I would like to go over. We just ran out of time, but it's on page 477. I would suggest that you look at that example on page 477 because that's kind of what these problems are going to look like. Let me give you some problems and then you can go.
Is it 9 to 24?
Yes, it is. You guessed it correct. So it's page 479, page 480, and it's 9 to 24. Okay? It's section 7.3. There it is. Have fun. Have it done for tomorrow.